Hi, so in this video, we have a new linear transformation which has a standard matrix as you see below. It goes from R5 to R3, and what we want to show is that this linear transformation is not injective. In other words, the size of the kernel of T, we want that to be more than just the zero element, right? We want there to be infinitely many elements in the kernel. And so we should suspect that this is going to be the case because we are, after all, going from a 5-dimensional space to a 3-dimensional space. And so it's going to be hard to do that without pushing some stuff together and thereby having multiple elements or multiple vectors map into the same vectors and being not injective. But let's work this out formally. So as usual, what we're trying to look at here is imagining some sort of hypothetical zero vector here and then seeing what its solutions are as an augmented matrix, i.e. computing the kernel of this thing. So let's see what this might look like then. So we'll go ahead and put in our 3 rows, 1, 3, 0, 2, -7. And just like before, I'm not really bothering with the zeros at the end. 3, I know what's going to happen. 9, -2, -5, -1. And in the last row, 0, 0, 0, 1, 5, -9. And if I do that, then what I end up with is, when I take this reduced row echelon form, I end up with 1, 0, 0, 3, 0, 0, 0, 1, 0, 0, 0, 1, and -3, 1, -2. And again, if we imagine that there was a 0 column at the very end, we can see here clearly that we have, or more like something like that, we have non-pivot entries, right? We have rows or columns that don't have pivots. So we have a free variable here, and we have a free variable here. And that means that the dimension or the solution space to this homogeneous equation has 2 dimensions, right? This is free, this is free. And so there are infinitely many vectors in the solution space, which is the kernel. So what we can conclude is that since the kernel has infinitely many vectors, T is not injective. All right, thank you very much. In the next video, we're going to take a look at the same T and ask whether or not it is surjective.